One of the important steps of site analysis is creating site models, both in digital environment and in actual model, as a solid model. Here, we need to create these models to understand the situation of the environment in a better way. And when we look at this model, once we create it, right, we can see it in a different perspective. And we can have something that we can combine all the data and see that in a better way, such as in this example. When I look at something like that, it's a 3D model, a digital model, and all the environmental data has been collected, has been marked on this model so that I can understand the situation in a better way with different comparisons, such as I can understand the heights of the building, the sizes of the plot, and their direction, the streets, street networks, the position of the sun throughout the year, and the wind, the water, and many other stuffs that I can add on. Greenery, social environment properties, historical buildings. This is very important for us because we need to see the big picture and we need to consider all the data together. Looking at them one by one, making an analysis in a separated way, concentrated on a different factor each time cannot be a better way. And as I said before, I need to create both the site model in a digital environment, and I need to make the actual model. But this is called a mass model because, as you see, the buildings are not modeled in detail. I can just see the masses of the buildings and the topography and the green spaces and the streets. This is what I need. So first of all, I need to decide how big a model that I need. And if I have a certain plot, the plot area, this area should be on the center of that model so that I can understand its relations with its environment. So first of all, I need to decide the sizes of the model, the boundaries of the model. If this is my area, I need to create a model at least this big because I want to see the seaside, get a glimpse of the sea. I need to see this main road here, this open area, these important religious, historical, and public buildings. Again, here there is one another, a synagogue. And this area should include my plot, obviously. And I need to create a SketchUp model like this, or I can use 3D Studio Max or any other modeling program software. And I can create an actual model. For the actual model, these can be my scales, 1/1000, 1/500. I need to decide if creating a 1/500 model will end up with a very big model in a very big size, then I can just arrange its sizes, or I can decide to change the scale so I can have a larger environment. The larger the area, the better it is. In my opinion, changing the scale with a larger environment, including the sea, the creational area, recreational area, and all these important buildings around, is a better choice than this one. And I need to create another model, this time very zoomed, very close to my plot area. Again, I can just zoom in the digital model that I use. And for the actual model, I can create another one in a bigger scale. Here, again, first I need to decide the sizes of the model. If this is my plot area, if this is the place that I'm going to insert my design, then I need to have a size that shows all its neighbors. This plot area belongs to this block. That's a building block here. And I need to include at least one neighbors from the neighboring plots here. So this is how I can decide because I need to see its relations. The whole block area, its relations with its neighbors. And for the actual model, again, I have two options. I can create a model in 1/100 scale, but first, before starting doing the model, I need to calculate its final sizes. If it is a very big model that I cannot be able to carry to school, to home, then I can rescale it. I can use 1/200, or I can resize it. I don't have to make a model this big. I can just move this line, this boundary up here. But please do not forget, it's important that you need to create your models with its environment, not creating a model in this size, just showing this building is not enough. You need to consider its environment, its neighbors. That's very important because first, you need these models to examine it in a deeper way. You need these models to place all your environmental analysis data. They are going to overlap and you will be able to see it in a better way. And especially this model you created, you are going to use this for a basis of your design. So that's very important to show, to create your model with its neighbors. And for the actual model, first you need to find out the contour lines. In some maps, they are already on the map, drawn. So if you have an opportunity, then you can just take that map. But if you don't have contour lines on the map, but instead you have these numbers, which represents the height of that particular point from the sea level, such as this is a map of Levant, Istanbul. Here we see that at this point here is 134 meters high from the sea level. However, if I go to this direction, it changes. It's 126 meters high at this point. So I can say that there is a slope towards this direction. I can just use these numbers and create the contour lines by myself. And once I get the contour lines, the only thing that I need to do is I can print it in 1/100 scale, and I need to cut these contour lines and place them, cut these contour lines and place them on a cardboard or any other materials so that I can be able to cut them. And once I place every contour line on top of each other, I will get a topography model. This is what we see. First, I created the contour lines. I draw the contour line by using that numbers. After that, I need to elevate them one by one. So I can use a model material, which can be a cardboard. But the important thing here is if these contour lines represent 1 meter heights, like this is a 134 meters, and the next one is 132 meters. 131 meters. They are 1 meter apart. So I need to find a material which represents 1 meter height in that scale. So by cutting these contour lines, using that material and placing them on top of each other, I will get the actual topography of that place in that scale. So I need to decide the thickness of that material. I can use corrugated boards, cardboards. In Turkish, we call it oluklu mukavva, or we have artificial rubber, which in Turkish is called eva. This is a very soft material. Preferring a soft material will be easier for you to cut these contour lines. These are its other names, or you can have actual cork boards, mantar levha, or maket kartonu. As you see, they have different thicknesses, so you need to calculate if you are making a model 1/100 or 1/200, how much 1 meter with how many centimeters a 1 meter, actual 1 meter will be represented in that model. So you can buy that board at that thickness, and you need to place the paper that you have cut with your scissors on top of that board, and by using a stationary knife. But I advise you to get, if you have the opportunity, one of these, not this one. These are, they don't have a very nice quality. And maybe you need to get a gray board, gray cardboard, or a cutting mat like that to protect the surface of your table, and a metal ruler like this, so that by cutting each line, and by adding it on top of each other, you will get the actual topography model. Also, you can do it like this, layer by layer. But at the end, if you have lots of contour lines, it will be very expensive for you, because you will need so much layers, and it will be very heavy for you to carry with you. So you can make a model with an opening like this, and it will be lighter and cheaper. Once you finish, you can just cover the sides, so we will not be able to see what's inside. Of course, you can just cut them by yourself, or you can go somewhere with a laser cutter and create those layers with the laser cutter. When you are trying to model the area in a 3D software, you will experience nearly the same thing. You can make a model like this. You can elevate these lines one by one, or with different plugins, you can create a terrain shaped like this. Either way, it's accepted. And once you finish with the topography, you can add a colored cardboard to represent the roads, and you need to make the buildings in that mass style. As you see, these are all buildings, but they don't have any details. We don't need to show the windows or the doors or the actual shape of the roof. I can just make a mass model like this. Let's say that one story is 3 meters high, and this building here has like 3 stories. So that is nearly, approximately a 9 meter height building. So I need to create a volume like this, which represents 9 meter height at that scale. I need to calculate it first and find the material to cut the buildings. As you see, it's again, I can use the same material. and place as many layers as needed, as required on top of each other. So at the end, I will get a form like this, or I can change the material. There are some other options, such as these EPS or XPS boards that you can purchase from stationaries or building material markets, and you can cut volumes like that. Or again, you can prefer corrugated boards. You can have them cut by lasers, or you can cut them by yourself. And once you added enough layers, you will get the building. Or if you want to create a cheaper and a lighter model, you can have a thinner cardboard and raise them with other stuff between each layer. So let's say that this height represents a 3-meter height in actual size. So this is a building with 1, 2, 3-story height. You can do it like that. And once you finished with the roads, with the buildings, building masses, you can place the trees. And there are some different options for you to make the trees. Here, I want to show you my Pinterest website. Here, if you want, you can see different options, such as these images. You can copy one of them and prefer an easy one, maybe. And you can look for different options here. There are different groups, folders that I have created. Here you see, yeah. This folder is just for model making. So you can, before you start doing your model, you can look for different examples here and decide one of them and do your model like that.